Hey everyone, Nitesh this side. So let's start with the question. So the question is subarray sums equal k. So you are given an array which is integer nums and an integer k. Okay, and you have to return the total number of contiguous subarray whose sums is equal to k. Okay, so let's see with an example. So let's take this example 1, 2, 3. Okay, so 1, 2, 3, and you have given a k as 3. Okay, so you have to find the subarray from this array. Subarray is basically is a contiguous array. So this is a subarray, this whole is a subarray, and this single element is also a subarray. Okay, so if you can see, we can find out all the subarray. Let's say this is 1, 2, 3, and other subarray basically 1, 2, then your 2, 3, and the final subarray is 1, 2, 3. Okay, so if we do the sum of subarray and we get the sum is equal to k, that we need to count. Okay, so if we can see for this will be not there, so we will not take this. Okay, this is also not equal to k, so this will also not, this we will not take it. Now this 3, so 3 is equal to k, so we will take it, so our count will become 1. Okay, now if we calculate the sum of this, 1 plus 2 is 3, so we will update our count by 1, so now count will become 2. Okay, so similarly if we see for this, it will give 5, so we will, but 5 is not equal to k, so we will not take this. And if we calculate the sum for this, 1 plus 2 plus 3, so it's 6, so 6 is not equal to k, so we will not also take this. So our output is 2, so we need to return this output. Okay, so let's take another example. So if you can see for this case also, if we see this subarray, this 3, 4 is giving the sum as k. So similarly, this 7 we can also take. So this is also one subarray. So we don't need to give the subarray, we just need to return how many subarray are present in this array, which is equal to k. Okay, and there is one more. If you can see, 4 plus 7, which is 11, plus 2 is 13. So let's take 4 plus 7 plus 2, 13. 1 second. So there will be other option also. So we need to return the basically this subarray that data that their sum is equal to k. So if we go with the name approach, what I was thinking is create all subarray. Okay, and whenever whenever we're creating the subarray, we will calculate the sum also, and if the sum is equal to k, we will increase the counter. Okay, now if you see, the complexity for creating the subarray is order of n square. Okay, so if you write the code with this approach, your code will be submitted. But let's see, can we optimize this more or not? Okay, so as our previous approach is good, like it will submit your code, but it takes order of n square. So can we do this in basically in a single loop? Okay, so before going to the second approach, let's calculate the prefix sum of this array. Okay, so we will calculate the prefix sum. Okay, so what we will do, we will calculate, like we will directly take the zeroth element as it is, and for the previous, for the one, we will add it by previous element. Okay, so it basically we will add this to this. Okay, so it will become 7. Similarly, we will add this to this, it will become 14. Similarly, when we add this, 14 plus 2 is 16. Then 16 minus 3 is 13. 13 minus 1 is 12. 12 plus 4 is 16, and 16 plus 2 is 18. Okay, so why I calculate prefix sum, I would like to give you some reason. Let's say if you want to calculate the sum of this array, this subarray, how can you calculate? Like you have to do the count for the counter, you have to do with loop wise. Can we basically do it like this? If we know the prefix sum for this index, okay, So we know the prefix sum of this array, this index, and if we deduct it from this point, okay. So first of all, what will be the sum for this subarray? It will be 7 plus 2 minus 3. So it will be 7 plus 2, 9, minus 3 is 6. Okay. So what we will do, we will basically at 4 we know the subarray sum, the prefix sum is 13. Okay. And we just do 13, basically sub prefix of this I, basically 4 minus prefix of index 1. Basically, I will do the I minus 1 and minus 1 basically. So it will be 13 minus 7 equal to 6. As you can see, we got the same sum. Similarly, we can calculate for this subarray also. Let's calculate for this. So it will be minus 3 minus 1 plus 4. So it will become 0. Okay. So let's see if we can see the sum at this point is 16 and sum at this point is 16. So 16 minus 16 is 0. Okay. So what we will do, we will follow the prefix sum approach to our second approach. So we will calculate the prefix sum. Okay. Now, whenever we calculate the prefix sum, we will check two things. Okay. So let's see. We will calculate prefix sum. Okay. So we just write it here as 3. Okay. And we need to check two conditions, whether this prefix sum is equal to k. So let's, if our current sum equal to k, then we need to do something. And also if current sum minus k basically is present in map or not. So if this is present in map, okay. So we'll explain with an example. So if you can see, if our sum become current sum minus k, let's say it will be some value, okay. And current sum equal to k plus value. So if we find out any value that is present in our current sum, so that means k will also be there. Okay. So let's see with an example. Okay. So let's see this 3. Okay. This 3, is it equal to k? Is it equal to k? No. And we also need to check if 3 minus 7, is it present in prefix map? Basically, I just write map, so it will be prefix sum array. Okay. So I will check is equal to minus 4. Is it present in prefix sum array? No, it is not also present. So we will move forward. Okay. So we will take this and now our prefix sum becomes 7. Okay. So we need to check whether this 7 is equal to k. Yes, it is equal to k. So what we need to do, we need to increase our counter by 1. Okay. So we will increase our counter. Now our counter is right now is 1. And we need to also do one thing, is check 7 minus 7 equal to 0. Is 0 is present in our prefix array? No, it is not present. So we will move forward. Okay. So we will take this. We will do 7 plus 7 is 14. Okay. So we check whether this 14 is equal to k. No, it is not equal to k. So we need to do second condition, 14 minus 7. Basically what we are doing is removing the previous sum, the kth sum, and we just removing this kth sum from current sum, and we check whether this value is present in our prefix sum or not. If it is present, that means k is also present. So we will do 14 minus 7 equal to 7. So as you can see, 7 is present in our array. So what we will do, we will just do count plus equal to 1. Okay. So now this will, now our counter become 2. Okay. We'll move forward. This will become now 16. For 16, we again check, is it equal to k? No, it is not equal to k. For 16, we will do 16 minus 7 equal to 11. Is 11 is present in our prefix sum? No, it is not present. So we'll move forward. We will do 16 minus 3 is 13. Okay. So again, 13 is not equal to k, and 13 minus k, which is 13 minus 7 equal to 6. So 6 is also not present. So we'll move forward. So now this will become 12. For 12, we again compare it with k. No, it is not equal to k. For 12, we do 12 minus 7, which is 5. And 5 is also not present. So we'll move forward. We'll now update 12 plus 4 is 16. Okay. So 16 plus 16 is equal to k. No, it is not equal to k. And 16 minus 7 equal to 11. So this is also not present in our prefix sum. So we'll move forward. Now it will become 18. So 18, is it equal to k? No, it is not equal to k. And 18 minus 7 equal to, here it is 9. Sorry, I just calculated wrong. And 9 is also not present. And 18 minus 7 is 11. So 11 is also not present. So now our final answer is 2. Okay, so if we calculate the time complexity for this also is order of n square, basically n for iterating for each element, and what we are doing is basically checking whether it is present in our array or not. So if you can see, we can approach this, we can, sorry, optimize this. So what we can do, we need, like, it will give in order of 1 that element is already present. So what we can use a map. Okay, so our prefix sum will create is type of a map. Okay, so let's see. Let's go with the same example. What we will do, we will create a map. Okay, we will start from here. So first 3 come. So we'll insert these 3. Right now we'll calculate the prefix sum also. So this will be clear to you. So we will insert 3. This will be a sum, and this will be a frequency of that. So it will become 1. Okay. Now our prefix sum will become 7. So we'll insert this 7 in our map, and our frequency will become 1. And whenever we inserting, we need to check the 2 things basically. Let's scroll back. So for 3, we'll need to check whether 3 is equal to k. So 3 is not equal to k, so we'll not do anything. And 3 minus k, which is 3 minus 7 equal to minus 4, and minus 4 is not present. So what we will do, we will move forward, and now becomes 7. So 7 have a frequency of 1. For 7, we again check whether 7 equal to k. Yes, 7 equal to k. So our count will become 1. Okay. And 7 minus k, basically 7 minus 7 equal to 0. This is not present in our frequency map. So we'll move forward. So we will take this. Now our prefix sum will become 14. We need to check whether this is present. Not, it is not present. So we will insert it. 14 have a frequency of 1. And what we will do, we will check 14 is equal to k. No, it is not equal to k. And we will do 14 minus k. Basically 14 minus 7 is 7. So it is present in our map. So what we will do, we just do count. And how many frequency are there? There is only 1 frequency. So we'll just update it by 1. Okay. So we will do the same for all the elements. So if you calculate the time complexity for this, it is only order of n. Basically, we'll, for all the element we are iterating, and for getting the element from a map, it's order of 1. Okay, so let's write the code for this. Okay, so what we need is length of an array, start length. We need a counter variable and also a current sum. Let's give a prefix. Okay, we'll create a map of integer, new hash map. Now we'll insert the element in our map and side by side check the two condition. Okay, so we'll do for int element nums. What we will do, first increase our prefix sum plus equal to element. We need to check if prefix sum is equal to k, then we do something. And also we need to check if map dot contains key prefix sum minus k. If it is present, then we need to do something. And lastly, we need to insert that into our map also. Map dot put prefix sum and get the default value or the actual value. It will be prefix sum, give the default value as 0 and just increase it by 1. Okay, if it is equal to 0, so we just increase our pointer, the count variable, and if it is present in our map, so what we will do, we will just get that value, map dot get prefix sum minus k. After that, we just return our count variable. Okay, so let's run the code. So as you can see, this is accepted. Let's submit it. So that's it. So that's it for this video. Thank you for watching my video.